Here's some bootleg audio modulation that I've got going on. Again, I'm using this PWM, and I decided that if it came down to it and I popped a FET, I would steal the one off this one. It's a 460. But before that happens, I wanted to see how I could get this going. I tried this a while back on the very first plasma flame circuit that I used, and I was afraid to use the audio output from my computer to where I could, amplify the signal a little bit. So I ran it straight off my phone through a Bluetooth module, and the signal just wasn't high enough. It was barely audible, but it technically worked. So this time I've got it going straight to the computer, and I've got a earth ground hooked up to the negative rail on this PWM here. So this is the PWM that I more or less use for audio modulation at the power rail, and I kind of figured this might work okay since this particular circuit doesn't have that DC cap on it. And it sounds like crap, but technically it works. So what I'm going to do is, as per usual, I have to, the way this works, you can't modulate the audio drawing a full flame. You have to vary the duty cycle just right. So I'll have to adjust this duty cycle to the point where it more or less sounds the clearest, and a lot of times the frequency has a lot to do with that also. But with such a high frequency in this circuit, I really have no idea how to cater it to that, but it does kind of work. So let me see. I'm going to start the music, cut that on, and then draw this out. So just cut it all the way down. So you can see in concept that's how it works. I mean, it's not going to pull anything. And on another aside, it's sort of a way you could regulate the power if you didn't want to adjust the input voltage. then I can actually regulate the output by just cranking the duty on here, as you can see. And actually, I can hear the music playing through the coil by itself before the breakout. I can pull a little tiny arc to get the music sounding better when it's got minimal current draw, but I really have to crank the voltage up to about 30 or more and push considerable power before I get better audio from that flame. And right now I'm honestly too lazy to set my fan up to keep all these cool. It's a little sync on the PWM. That's probably going to get warm, but I mean, you can see, there you go, it works technically. And you know, the audio doesn't actually sound all that bad if you get the PWM tune just right. And again, this is probably one of the worst ways to do it with this setup on the power rail, but it still works, so that's pretty cool. So a blown fuse I've put on there. I've already cut it on, and it does want to form a channel in the glass. That little cool little red channel that it's burned across the glass because the fuse is blown on the inside. And that cap sort of immediately broke off. So if I cut it off, that glass is just sort of turned like molten black. Cut it back on. So yeah, that's how hot those flames get. It's basically turned the that little cylinder of glass to a conductor, more or less. And there it is without the little cap on it. So breakout point's just touched to the little bottom plate there, and it's still breaking out the top. Well, that's kind of cool. So I got a all glass breakout point there. Don't have to worry about the flame trying to dance around and just break out on the screw portion or whatever I use as a metal breakout point. It's just all glass now. That's a pretty nifty way to do it. Wonder how long that will last at higher power though. And I've got my fan recharging, my fan battery recharging, so I don't want to crank it up too high, but let's weather it up a little bit more. That's about 130 watts though. So yeah, that's a cool breakout point. I think I might stick with the just use a dang fuse as the breakout point. So I'm going to cut it back down to about 30 volts and then cut it back on to see what it does. So I'm going to get it going. So you do have to draw it out. It took a little while to burn a little channel in there. Then you can draw it out. That's cool. But I have to cut my pot down a little bit. So there we go. That's pretty cool. This is not my ideal coil though. The former is a little bit wider than I'd want it to be. I realized that this gauge of wire worked pretty good, 32, but I've been using plastic formers, and eventually those just all warp. so it just didn't work. I ended up using this little glass former here, but this actually does work fairly well. But the switching isn't as ideal, and it just pulls too much power to get a impressive flame. This one's been running for a little while. It is starting to heat up a little bit. But you see, I've got this wound on a glass former, and the diameter is a little bit wider than I would have preferred. So this is probably not going to be the final one, but just wanted to show. So if I cut this one up, I'll just cut that one up to. So I've got the gate voltage down a little bit, but I've also got it slightly detuned. But this one runs pretty good. There's no glass on there, but it's a very hot arc. So you see, eventually it just starts basically burning that tip down. You see, that's the little screw there, just annihilating basically. Cut the gate voltage back down. So that does pretty good with some glass on the tip. But I intentionally put a small screw on there just to burn it down. It's kind of cool. But I also wanted to mention that I tried coils with significantly thicker gauge on a former that would end up like this. And this is when I did eventually end up popping a MOSFET, getting sort of cavalier with the tuning there. And what happened with that one was basically I was cranking the frequency up, and I heard a lot of popping in the cap, and then the FET died. And that was one of the 027Hs. And I did have another one handy on a PWM, so I replaced it. But for whatever reason, when I up to about this gauge of wire, things start to get more complicated. Whereas sticking with about 32, and this is about 26, haven't really had any problems. But I will say, for whatever reason, using the 32 gauge wire was probably my favorite. It seemed like I don't know if it's catching harmonics or what, but it seemed like it was much more robust. There wasn't a whole lot of strange dips and peaks and just varying frequencies that this thing might pick up depending on my tuning. The only problem is I need about twice this height, but I might still end up using this just because it's pretty cool. But like I say, the glass former was pretty much necessary to run it long periods without deforming the actual former.